Okay, so this is how you find the domain of composite functions. Now these two examples I would call more on the difficult side. There's a couple tricks involved in this, so it's not as easy as the other ones that you may have seen. So notice on number one here that two functions are given to you, and you're asked to state what the domain is for G inside of F, and then also F inside of G. So notice as I already have a skeleton for both problems, and I'm going to put function G inside of F, and when I do that, I get that function there. Now, even though the original domain is x is greater than 0 here, and here the domain is all real numbers, once you put the function inside of the other function, you have a whole nother issue here. So we have to look at the resultant function here, and the domain would be x would have to be greater than or equal to 1, or x is less than -1. So the original function domain here is greater than 0, but once you insert the two functions into each other, you are going to get a totally different domain, so just be careful of that. Now conversely, if you go the other direction, if you put function f inside of g, you end up getting, let's see, this, and algebraically when you simplify that, you just get x minus 1. Now this looks harmless. It looks like the domain would be all real numbers, but it is not. And this one may be shocking to some of you because you've done some problems, you look at the resultant function, it appears to be all real numbers, and it'll say something very different. So you actually look at the original, you look at the function before you simplify. So you actually look at this before you simplify. Now according to this, the domain x has to be greater than or equal to 0. Now that may not make sense to you because it simplifies here to just simply x minus 1. It looks harmless. Now remember, when you do a composite function, look at where I'm drawing right here. If you're going to put in, let's say, -1. Now -1 works here. -1 minus 1 is not undefined, but if you were to put -1 in here first, it first has to pass through function f before it can ever get to g. And if -1 doesn't work in f, it will not make it to g. Therefore, that's why this is the domain you have to use. Okay, now the other little trickaroo here is on number 2. I'm just going to go one direction here. I'm just going to go g inside of f, and when you do that, you get 8 over x here. Now, we don't have any square roots, so we don't have to worry about negatives under a square root, but we do have a fraction. Matter of fact, we have two fractions. I'm going to call it a baby fraction. Here's our baby fraction. And then we have a big fraction. So we have the original function, which is 2 over that. So there are two ways that you can get a 0 on the bottom of a fraction. The first one is you can get 0 on the baby fraction. Now on the baby fraction, x can't be equal to 0. So that's one restriction on the domain. The other restriction would be that the entire denominator, so we have the big fraction here, we got 2 on top and we have this gigantic thing on the bottom. We do not want this to be equal to 0 as well. Now if you algebraically solve that, I'm going to subtract 4 from both sides. Okay, I'm running out of space here. If I cross multiply, I get that, and x equals a -2. Matter of fact, I don't want x to equal -2. Now just to show you how this works, first of all, x can't be equal to 0 because that will make the baby fraction 0. And x cannot be equal to -2 because if you let x be equal to -2, 8 divided by -2 is a -4, and a -4 plus 4 gives you 0, and it will make the ginormous denominator 0. So here is the other type of problem that's a little bit tricky as well, that you actually have two restrictions on the domain, because 0 will make the baby fraction undefined, -2 will make the overall fraction undefined, therefore you have two of them. So going back to the very first example, this right here would be the restriction on the domain. You have to look at the original function before you simplify, for the very same reason why I explained that that negative number would have to pass through f first before it can make it to g. So all real numbers would not be the domain of this.